Hi, so this is the video for Objective 3, which is difference of squares factoring. So we talked in the last video about what factoring is. It's identifying how did you arrive at the expression that you're given. What was multiplied together to give you that expression? And so in the last video we talked about greatest common factor, and that needs to be your first line of attack for all factoring questions. But then after you do that, you have to look at, is there something else going on? Or maybe you have a question that doesn't have a common factor. So how can you factor then? And the important thing is you need to be able to identify what kind of question it is. So we're going to flip over to our flow chart first. So this is what we started working on yesterday, minus this part. So last day we talked about the first line of defense, remove the greatest common factor. We looked at an example of what to do if that's the case. But there will be questions that don't have a common factor. So what do you do then? There will be questions that what is left remaining inside the set of brackets can be further factored. What do you do then? So number one, the kind of question we might have might be a difference of squares. And that kind of question will get factored in a very specific way that we'll look at in a moment. But to identify a difference of squares, you are looking at an expression that has two terms. There is a minus sign in between the two terms, hence difference, right? Minus, difference means subtracting. So there's a minus sign in between the two terms, and both of the terms are perfect squares. So it is a difference of perfect squares, a difference of squares. So a minus sign between two perfect squares, and that's how you identify it. You need to be able to identify them without having this flowchart. This flowchart is here to help you for the time being, but you need to commit these three criteria to memory. You need to know how to identify them. Okay, so let's go back and look at some examples. So the question that we have here, we have x squared minus 4. Is there a greatest common factor? That needs to be your first question for every question in this entire unit. Is there a greatest common factor? And the answer is no. There is no coefficient here. There's no number. So there's nothing that's going to be in common with this. And there's no variable. There's no letter here. So there's nothing to be in common with the x squared. So this question has no common factor. But you need to check it. That has to be your first step. So then you're down into the bottom of your flowchart where you're trying to identify what kind of a question is it. So the only one we know about so far is a difference of squares. So let's compare the criteria of a difference of squares to the question that we have here. Do we have two terms? Yes, we do. 1, 2. Is there a minus sign in between the two terms? Yes, there is. Are both terms perfect squares? X squared, that is definitely a perfect square. 4, definitely a perfect square, because that's 2 times 2. So then, once you identify that, yes, this is in fact a perfect square, then what you do next is you set 2 sets of brackets. 2 sets of brackets underneath. And then you identify what is the square root of x squared. And the square root of x squared is x. What is the square root of 4? The square root of 4 is 2. So the square root of the first term becomes the first term in each set of brackets. The square root of 4 becomes the second term in each set of brackets. And then to finish off your brackets, one gets a plus and one gets a minus. It doesn't matter which one gets the plus or the minus as long as one of them has the plus and one of them has the minus. So you might be thinking, I don't understand, like, why is that? How does that factor from that? And I want you to think in reverse for a moment. So in the fall, we might have done a question like this, and the instruction might have been FOIL. So FOIL, first, x times x, x squared. O, outer, x times negative 2, negative 2x. Inner, plus 2x. Last, minus 4. What happens to these middle two terms? Negative 2x plus 2x. Bam, canceled. So all you have left is x squared minus 4. So that's why a difference of squares doesn't have a middle term, even though it looks like it should based on what its factors are, because most of the time when you FOIL, you end up with 3 terms. But this kind of FOILing, you drop that middle term, you lose the middle term. So that is why that factoring works for x squared minus 4. Let's go through a few more examples. So 1 minus 25y squared. Step 1, is there a greatest common factor? No. No variable there, only a 1, nothing in common. Is it a difference of squares? Is 1 a perfect square? Yep, 1 times 1. Is 25y squared a perfect square? Yep, 5y times 5y. Minus in the middle, 2 terms. Set 2 sets of brackets. Square root of the first, 1 and 1. Square root of the second, 5y, 5y. 1 set of brackets gets a positive, 1 set of brackets gets a negative. Done. Next question. 2x squared minus 18. Top of the flowchart says, is there a greatest common factor? And the answer is yes. In this case, there is. 2 is common to both of those. So this first step on this one is going to be to remove the greatest common factor. So we write the greatest common factor down, open a set of brackets. 2 times what gives us 2x squared? And the answer is x squared. 2 times what gives me negative 18 minus 9. Close the set of brackets. Then you look at what's left inside the set of brackets and can you keep factoring? And the answer is yes, you can, because this has 2 terms with a minus in the middle. That is a perfect square, and so is that. So the way to keep going is to bring down your greatest common factor. That has to stay with you. And you're going to open 2 sets of brackets. Square root of this gives you x. Square root of that gives you 3. 1 bracket gets a plus. 1 bracket gets a minus. Next question. 4a squared minus 9b squared. Greatest common factor? No. 4 and 9 have nothing in common. A squared, b squared, nothing in common. No common factors. So now we're into the bottom of the flow chart. And do we have a difference of squares? Is there 2 terms? Yes. Is there a minus in the middle? Yes. Are both of the terms squares? Yes. So 2 sets of brackets. We square root the first to give us 2a. We square root the second to give us 3b. 1 gets a plus, 1 gets a minus. Okay, next question. Greatest common factor. No numerical component here, no variable component there, nothing in common. Is it a difference of squares? How many terms? 1, 2. Is there a minus in the middle? Yes. Are both of those terms squares? Yeah, absolutely. So 2 sets of brackets. Square root this gives you xy. Square root of 16, 4. 1 bracket gets a minus, 1 bracket gets a plus. All right, next question. So now we're into sort of the seemingly more complicated ones because they have bracketed components. Don't be afraid. I have full faith in you that you can do this. Is there a greatest common factor? This has no bracketed component, and this has nothing in front of the bracket that could have a common factor with 9. So we have nothing. Is it a difference of squares? Well, this is squared. That is square. So we've got 2 perfect squares. We've got a minus in the middle. And there are only 2 terms. So we're good. All 3 criteria met. So now for this one, I'm going to set large square brackets because I know that when I take the square root of this, I'm going to have x plus 2. And I'm going to keep that in brackets for the time being because this is x plus 2 times x plus 2. So the square root of it is just going to be the x plus 2. Square root of 9, we get 3. 1 bracket gets a plus, 1 bracket gets a minus. So in the last video we said that math loves simple. So the simpler you can make your answer, the more math is going to love it. So we need to look at what's left inside of these sets of brackets and look to see if we can simplify it. This is x plus 2 minus 3. So that can simplify to x minus 1 if we collect the like terms of the 2 and the 3. This is x plus 2 plus 3 to give us x plus 5. So the vast majority of these questions, the final factors are going to be identical to themselves, except for one's going to have a plus and one's going to have a minus. These ones are going to be different because you're going to have to do a bit of simplifying after you sort of do the initial difference of squares factoring. All right, last example. Let's tackle this one. Is there a common factor? No. No bracketed piece, no coefficient, nothing in common. Is it a difference of squares? 1, 2 terms, minus in the middle. 25 is a square, and this is squared, so therefore it is obviously a square. So 2 sets of brackets. I'm going to do large square brackets because I can see that this square root is going to be in brackets itself. Square root of the 25 to start. So 5 goes into both sets of brackets. Square root of x minus 2 to the power of 2 is x minus 2. One bracket gets a plus, one bracket gets a minus. Okay, so then we look to simplify because we don't want to leave brackets inside of brackets. So simplifying over here, we have 5 plus x minus 2. So the 5 minus 2 is going to go together. And that's going to give me 3 plus x. This one is a little different because this negative is like we have a negative 1 sitting out here that has to get multiplied into that set of brackets. So this is like 5 minus x plus 2. So then we have to simplify that a little bit more. So that gives us 3 plus x still, that's unchanged. But now we have 5 plus 2 to give me 7 minus x. Okay, so that about does it for difference of squares factoring. Enjoy!